So our first speaker is Mike Bennett from Rolls-Royce. Mike's a software technology specialist working in research and technology. Mike is a software specialist working for Rolls-Royce Control Systems in Solihull. He's leading a 3-year ATI-funded collaborative project with 11 other partners to reduce software costs and timescales in the aerospace industry. And the presentation title is SECT-AIR, a UK initiative to reduce aerospace software costs. Over to Mike.
Good morning, everybody. I think that was a good introduction, so I don't really need to tell you much more, so I can go and sit down. I'm feeling slightly apprehensive because there's so many people in the room today, and that's not the only reason. So I'm kind of a software specialist, and I know there's a lot of you in the room who are hardware experts, and I don't really know too much about hardware. So it's going to be a fairly high-level overview of a software project that we're doing in the UK. So we are running, as was just said, a 3-year project to address software costs and timescales associated with aerospace and high-integrity software in the UK. It's a big consortium, so we started this July last year, and we've been running it since then. It's obviously early stages, but so we want to get a bit more information out into the public domain. A lot of people have been coming to me. There's been a lot of interest as words kind of got out there that we're doing something. It's a project that's co-funded by Innovate UK and through the ATI, through the Aerospace Technology Institute. And I'm going to tell you a bit about why we're doing it. And to do that, I'm going to kind of use a bit of the background to why Rolls-Royce wanted to get involved in this initiative. We have the benefit of having, I think, 5 partners from the consortium here today, so I think you'll be hearing from a couple of them later. So that's good, bit of moral support in the audience. I can see that Stuart is either taking a picture or videoing me, so thank you, Stuart, for that. So a bit about Rolls-Royce. So what do you know about Rolls-Royce? Well, we don't make cars for a start. We make large gas turbines, so top of the market gas turbine engines, and that's on some of the wide-bodied planes that you fly about and your families fly about in the world today. I've just got some pictures there of our technology. Don't want to dwell on it, but I'm going to relate it back to why we've got challenges associated with software. So on the left we've got the Dreamliner, and that's actually the latest stretch variant of the Dreamliner. And that went to certification with our latest engine last year, and I think that might be a picture of actually the Trent XWB EC, but that's the black box that we produce in Solihull, the engine controller unit that we produce. On the right hand side we've also got the Airbus A350, which is a massive program for us. And on the bottom right we've actually got some new technology that we're developing, so the next generation of engine. So we've got a lot of challenges at the moment, and one of them is to stay ahead of the game. So we're investing a lot of money in what we call our UltraFan core, which introduces a lot of different technologies and brings a lot of technologies together. So it's got a very big gearbox in the middle to slow the fan down so we can get better efficiency. But that's all engine technology, and I don't know anything about hardware verification, and I certainly don't know anything about engine design, but what I do know is the complexity that's been introduced into the system to help us manage these type of products. So that's all the good news stories, and what really my bosses would be probably pretty nervous about me showing is some of the bad news stories we've been seeing in the business recently. And I don't have pictures of that, but I can sort of talk to it. So last year software was on the critical path for the Trent 1000-10 program, and that's pretty typical nowadays. We see a lot of the airframers doing engine-only updates, and that means there's very little else changing on the aircraft apart from the engine. And when the engine changes, obviously you've got all the mechanical stuff to do, but a very large proportion of that is the control system, and at the heart of the control system is the EEC, and at the heart of the EEC is the software. And typically in one of those EECs you're going to be looking at 300,000 lines of code, maybe more, maybe a bit less in some of our smaller engines. And we try to reuse a lot of software, as you would expect, but even when we do that, we are still experiencing longer and longer program durations, more and more complex functions that need to be integrated, and this is causing more and more high-level stress within the business about how to deal with this. So Rolls-Royce really wanted to be leading a program to look at how we can reduce software costs and timescales. And this all when we're aiming to bring UltraFan product to market in the mid-2020s, but in order to do that, you can work back from there and say we need sort of a 10-year technology and development program to get there. So if we don't have these next generation software verification and software development technologies in place, we're not going to be able to feasibly afford the types of control systems we need to put on that engine. So that's kind of the reason we wanted to be involved in this project, and that's kind of I won't say it's exactly the same story for everybody else in this consortium, but it's a general trend that we saw when we were talking in the gestation of this project, that companies were seeing stress around the generation of software for their products. So you probably know the story. We've got a large amount of safety critical technology in our products. All our engine controllers are all level A at the moment. So all those 300,000 plus lines of code are level A. The amount of safety related functionality is growing rapidly, and our avionics programs are really are becoming difficult to afford. I won't say unaffordable because we're still doing them. I think we've got something like 7 parallel programs at the moment, which is really hurting the business as well. So we are like sucking up the UK supply of software engineers, safety engineers, verification engineers, and you can imagine how difficult that is to manage. It's difficult to sustain. So one of the only levers we can pull at the moment is offshore, as I'm sure you're all aware, but it doesn't really address the underlying productivity issues we have, and also lowers the barrier to entry inevitably, because you start giving them kind of verification tasks and they pick up a few design tasks, and you know, we want to keep the IP and keep the intellectual property within the UK. So around the consortium more generally, the amount of money, I think, don't have the figures here, but in the business case for this project, we put together a very large figure for the amount we spend on software every year in the consortium. So our goal really is to sort of transform that, so that exponential growth in the cost of software. I've got no scale on the graph because I had it the wrong way around, so I had to kind of muddle with the slide, but that's kind of showing that the cost of software is growing fast at the moment, and we need to get that back down to a manageable level. We worked with the ATI and Innovate UK to get this project launched, and it's recognised in the ATI strategy as requiring a sort of pan-industry effort. You know, I think Rolls-Royce, we do have a tendency to think we can do everything ourselves. If you look back to that engine controller, we develop all the software, all the complex hardware. The processor is our own, so we design our own processor. You know, we can solve this problem ourselves, but there are new techniques, and you know, there's vendors out there with all this new model-based tools, formal methods, and we need to engage with the wider industry to and share best practice as well. So we felt that a consortium-based approach was the right approach. To give you a bit more meat on the bones, we're now finding that if you look at the top half of that picture, that's the non-recurring portion of the total engineering costs for a FADEC over the lifetime of a FADEC. So we won't build, you know, we'll build thousands of FADECs, but really amortizing that cost of the NRE program is becoming increasingly difficult because as it's growing, and really the hardware costs are becoming a kind of the minority, so less than 20%. The majority of the program cost is the software cost. And when I say software, I kind of didn't mention it at the start, but I meant to, is that we're actually sort of including in our project complex hardware, so we see the same kind of life cycle pressures. We don't do as much complex hardware in our business, but it's seeing the same sort of cost pressures associated with it, so DAL A hardware and DAL A software. So there's some scary figures associated with that red portion. So, you know, we're in the tens of millions up to £100 million for a software development program. So it's quite a lot. So, and really this is a restatement of the problem. We know, you know, Rolls-Royce will only ship safe products and quality products, and all the members of the consortium would say the same. You know, their products are safe, and when we deliver them, they you know, people's lives depend on them. So safety, quality is not negotiable, it's fixed. So it's not just fixed by the standards, but it's fixed by our sort of mentality, if you like. But the scope is increasing, and therefore the cost is increasing, and kind of the only way to really address that is through getting some kind of productivity improvement. So automation, and I'll tell you a bit more about that later. Someone's going to have to keep me on track, actually, because I will talk forever. So tell me when I'm running out of time, please. So this is a keynote, so they said be controversial. So yeah. So what if we could do that? Engineering management would love it. So that you know, that's the typical challenge. You know, can you reduce software by 50%, 80%, some arbitrary large figure? But actually, when you think about it, I think there's no fundamental reason over the next 10 years why we couldn't do that. So why do I think that? Why do we think that as a consortium? By the way, that's not what we promised Innovate UK or the ATI. But if we can get towards a significant saving on this project, we'll be well on the way. And why does it cost so much? Well, I assume a lot of you have seen kind of 178C and DO254 standards. So, you know, you start at the top with some requirements that you get wrong. You go down and you get those ones wrong too, and you go down here and you get those wrong, and you get that right actually, and that's okay. But you got it wrong up here, so you go around the circle. This is, you know, I'm probably teaching you to suck eggs, so I don't need to kind of dwell on that. But the thing to bring out on here is everywhere, you're not meant to understand all the points in this, but the point is there's a lot of arrows there, and all of those corresponds to verification tasks that have to be completed. So we have to show, demonstrate, prove that we can meet all of those, and everywhere it's underlined, it's with independence, and then we have to verify that these ones on the side are particularly onerous. So there's a lot to do, and it's compounded by the fact that when we get it wrong, we have to go around it all again, and we do, and that's why our programs typically take, you know, a number of years, even for what might be considered not a dramatically different engine controller to the last one, but getting this right with the human in the loop is difficult. So it's a foe, right? We want to get rid of it. And there are some people out there who are looking at initiatives that would kind of allow alternative means of compliance, so showing safety and integrity by other means. And there's initiatives with the FAA. We know that there are suppliers of electronic equipment into aircraft who argue that this is too onerous. It's actually reducing safety. By making us do all this, we can't put our devices on the planes that will actually save lives. That's not something that that we think about the products we build. So, but there's maybe an argument there in certain cases. However, that's not the point of this talk. The point of this talk is to say, well, actually, that could be your friend, because it's a very clear, and it's been around since, I don't know, 178B was 92, I can't remember exactly. It's been there in stat form for some considerable time, and we're now beginning to see a large market in tools and competing tools, which is good for the kinds of things that will automate these parts, these arrows, allow you to generate this evidence with less overhead than you would do in a manual process. So it's creating that market. It's not fast enough. We want to speed it up, and that's the reason for SECT-AIR. So that gives you a pretty precise definition for what you need to do, and with a precise definition you can kind of work towards tools that will give you that. So it could actually be our friend. There are some other friends as well. So the supplements to the the base guidelines, if you like, which are supplements that allow us to apply formal methods, model-based development as well. And these are now actively, you can see around, not just research projects experimenting with these standards, but people actually going to the cert authorities with these kind of techniques and trying to argue that their technique is valid and certify products like this. You know, I don't know everything that's going out there, but I hear more and more about what's going on. You know, back when I was in university, a long time ago now, you know, formal methods, it was there like 1980s, and it was there in the 1990s, but it wasn't, because it wasn't used. So we've been waiting for these things to come along to be easy enough to be used to scale up to our industrial problems. But they're really starting to take hold. Okay, so I guess it's a verification conference, so I wanted to talk about verification. Another apology, I'm not a verification engineer. I don't know as I've ever written a test, which is pretty damning, I think. No, obviously I've written loads of tests. So what are the problems we see associated with verification? So this is kind of a Rolls-Royce kind of perspective because I wrote the slide, but yeah, hopefully around the consortium they'd recognize this. So typically verification, because of the size of the problem that we work on, verification is disconnected from the design process. You've got separate teams. There's always that independence kind of lurking there. Oh, you need to have separate teams. Not sure about that. We have a lot of residual low-level quality issues. When you've got a standard such as that, you're going to make minor issues. We know this. So there's going to be typos in the requirements, but they all build up as quality issues. You raise them as problem reports within the system, and then they have to be managed, and then someone has to manage them and prioritize them and deal with them, and they kind of drag with you as your program carries on, and then you have to explain why they're okay to the customer. You don't want to be doing that. Compounded by offload, not because we don't have highly skilled offload, we do, but it's that kind of, they're a long way away. It's kind of difficult with time zones to talk, and it may, you know, it's just the fact they're not co-located can be a problem. So, you know, it's not, and they also don't necessarily always understand our process straight away, so we have to bring them up to speed. So there is some issues there. The big one for us really is that where it occurs in the life cycle, obviously verification is occurring at the end. So really the one for us is potential to impact the certification date. You know, there's when it's close to certification in our offices, you know about it. You know, people don't go home, and you know, we need to get away from that mentality that you know, there'll always be a struggle to hit a deadline, I'm sure, but the level of effort we have to put in the push to get to certification is really quite remarkable. Test levels are disconnected, so you know, we do unit testing, we do software integration testing, hardware-software integration testing, and system testing. They're kind of, you know, they're a bit disconnected. The coverage is not necessarily as integrated as it could be. And then there's the kind of thing that, you know, as a design engineer or whatever I was years ago, an integration engineer, you never saw any value in the unit testing. You know, it never finds anything, never finds any bugs. That's not probably true too much, but there's a lot of testing that we do, especially at the lower levels, that doesn't add value. So how do we add value with the testing? So that's all the bad news, but what's the good news? Well, we're doing something about it. So thanks to Ultram for this slide. The way we see SECT-AIR working, you know, we see it helping to transform from labor-intensive processes supported by poorly integrated tooling to well-integrated tooling that we can use automation with. So how do we do this? Well, you know, I'm sure 10 minutes to go. Cool. Oh, that's quite good actually. Not doing too bad. We know the technology exists. You know, these techniques have been out there for a long time in academia, in tools, in products, but they're not always still embedded in the high-integrity aerospace sector. And there's a lot of reasons for that, a lot of good reasons. So you know, once you've got a well-established process and you're running a a big project, it's very difficult to switch to these new technologies. Just that kind of getting everybody bought into it, getting the whole business bought into it, putting the investment up front, and then sometimes it doesn't work as well. You know, not every egg is a bird, as one of our leaders always says. You know, you try something, it might not work. If you try it on a high-risk project, there's going to be there's going to be, you know, a lot of risk associated with that, and it sticks in people's memories for a long time. So, you know, what we want to do is prove some of these technologies in demonstrators. You know, we would like to embed some of these technologies in our engine demonstrator, which we've not always done. So some of these component technologies, software, you know, software has often been regarded as something we pour in after we've done the hardware. You know, just give it some software so it'll work. Well, no, if we do that, we're not going to be able to afford the product, the real product. So we want to embed some of these technologies into our demonstrator projects. Oh, that's a busy slide. I'm going to struggle to explain that one. Those are some of the ways in which we envisage SECT-AIR helping. So prior to SECT-AIR, we and some of the others recognised that we weren't, you know, collaboratively engaging with other people experiencing the same problems, the tool vendors, the universities. As much as we could do, we're too focused on our own problems, so wanted to develop a sort of collaborative industry-led strategy. Wanted, you know, grand aims, you know, we're not going to achieve everything in here, but align better industry and academia, exploit some of the technology coming from the faster-paced domains, the automotive sector, for example. Mature, this is a key one, just maturing our processes and technologies. You know, people say, you're always maturing, you're always asking for the next case study, the next piece of research funding to do a bit more, but we just need to keep doing it, and eventually it will come good. I'm convinced of it. Validate it using representative case studies. You know, metricate it. Let's have some science. It's difficult, as Nick will agree with me. It's difficult to get a well-validated scientific study of how one technique compares to a sort of more manual technique, a new technique compares to a more manual technique, but we need to try and do that sort of thing. And then the benefits on the right-hand side, I don't need to read all those out. So what are we doing? Another busy slide. One of the reasons for giving this talk is that this material will be available afterwards, so people can engage more on any of the particular topics. So I'm not going to go through all of those. We're going to pick out a few of them. So, you know, big focus on getting it right up front, more formal, modelled, less ambiguous requirements. If it, you know, our requirements could and will be better in the future, we need to get that handover from the systems engineering process to the software process and the hardware process better. 5 minutes. The kind of collaborative aspect of the program, so developing guidance, guiding the industry, creating an ongoing forum. So in the future we hope to bring together more partners in the UK who would be interested in participating in some kind of forum, which we haven't scoped out just yet, but we're in the process of looking at what that would look like, metricating what we do today. And on the right-hand side, I guess what this conference is most interested in is the verification process. So, you know, automating that verification process, whether it be automated testing, formal methods, proof, you know, looking at better tooling, better architecture, so better structuring of our systems that are growing, so drawing better boundaries between components in our systems. And then it's not an afterthought, but it's a separate work package on, you know, these same techniques but applied to complex hardware as well, and looking at some of the crossover challenges, multi-core processing, for example. So how does that all simplify right down to? So I think when I started this project, I was thinking, automation, we need to automate, we need to automate, we need to get our process slicker. But, you know, really quickly, you realize you can't do that unless you get the design in a form that can be automated. So you need to get it in a kind of automatable form, a formal form, semi-formal form, anything that's not kind of, you know, badly written English. So that's what kind of we're focusing on. And here's an example. It's not SECT-AIR, but this is a project that Altran were leading, and it's kind of an exemplar for what we're trying to achieve. There are different little sub-projects within our wider project that are kind of doing the same sort of thing, taking a technology, proving it on an industrial example, and then, you know, making it ready for industrial adoption. So Ottos AK is automated testing of Spark ADA contracts, which is a bit of a mouthful. Thanks to Stuart for that one. Was that your acronym? So I mentioned before, we spend a lot of time and with a lot of people developing unit tests. I'm sure other people would recognize that within the room. Now, a lot of that test process can be automated, but we typically wouldn't be able to claim credit for it unless it's proper requirements-based testing. So we need to be able to take the requirements and use the requirements to generate the test, not just get coverage, not just chuck a load of tests out and get coverage. So this is using Spark or a formalism, and this is an example of a formalism. There are many other formalisms, but using a formalism to allow you to use a bounded model checker to generate your test cases for you, so basically taking a human out of the loop and claiming that cert evidence, but reducing the amount of effort required. So this is an example of the type of technology that we want to mature on SECT-AIR. There are many others. So I think I might hit about the right time here. So as a summary, software cost and timescale reductions are really critical for us and for the whole consortium, and I think they're critical for the whole of the UK aerospace industry. SECT-AIR brings together a large proportion of key UK capability. It's not got everybody in there, and that's something we want to address sort of as SECT-AIR matures. Verification is really where the time and the cost are. We can automate this, but we can only do it if we've got a really robust design. So I'll go back to my, is 80% possible? Well, it should be, but let's commit to some kind of a step change. So thank you very much. That's...
Thank you. Thank you, Matt. We do have time for a couple of questions. Further question. I've got two hands. Do you want to say anything?
Hi, Aviv Bakai from Intel, Israel. How do you handle the requirements? Because you're actually saying you need very high quality requirements, both at the high level and at the low level, and specific language perhaps in order to automate the creation of testing from it.
Yeah, so there are a number of different approaches we're looking at. So we're looking at a couple of projects to do with structured natural English that can be mapped onto a formalism and then translated. I mean, maybe John, maybe Nick can help me out with this one, but we can talk offline. But that's one way. We're looking at putting formalisms against existing tools that are out there that are sort of semi-formal, if you like. There are many of the products on the market. I don't want to name particular tools, but putting formalisms around those tools and being able to prove that equivalence at different levels and prove equivalence between them. I don't know if that was badly enough explained, John.
Okay, thank you. Are you picking that up later, John, as well in your presentation? So this will be covered later, I think, in the final keynote as well. Okay. Sorry.
Yes. Just thank you very much for presentation. My name is Juan Llorens from Reuse Company. Do you mind to go back to 2 slides, I think? One more? There. My question goes in regards to your need, more intelligent, integrated, and lower cost tooling. Mm-hmm. And my question is, well, that would be the paradise, of course, but usually never that way, because if you want so kind of tools, they usually are not so cheap. Mm-hmm. So I would like to ask you, in the trade-off of getting these good tools but expensive, what kind of approach would you do? I mean, your company would simply don't buy tools to solve these problems, or they would buy tools because they are expensive, but they solve these problems?
Okay, let me think about that. Well, I think, so there are a number of different approaches. So sometimes we would invest in an expensive tool to automate a forward step in the design process, qualified code generator. However, that's not necessarily the only approach. In 178, you spend a lot of money developing a software development tool, TQL, whatever it is, I can't remember. But actually, it may be more cost effective to do a software verification tool that checks compliance, and the onus on certifying a software verification tool is a lot less, so it's a lot more cost effective. So that's one way we're looking at things. Another way for non-certifiable tooling, because there's a lot of tooling that we have around our development process that is non-certified but badly integrated. We have loads of document generators, code generators, traceability matrix generators and checkers. We need more powerful model to text and model to model transformation tooling that will allow us to process the data. So we're I think we're working, there's a work package within SECT-AIR on developing a kind of open infrastructure where you can bridge from proprietary tools through their interfaces they do all provide to allow you to transform into another representation, and then also improve the expressibility of the transformation language. So we've got a load of, well, I'll give you a noddy example. We've got a document generator that's thousands and thousands of lines of Visual Basic, awful to maintain, really kind of not very nice. With these tools such as the available in Clip, so the Epsilon framework that will allow you to generate document generators very concisely and easily compared to the technology that was available 10, 15 years ago. So it's about getting the consortium familiar and up to speed with a lot of those tools that are around today but we've never used before, so trying to embed them within industry.
Okay, I think we better end there. Thank you very much, Mike. Thanks for the questions as well. So thank you very much, Mike. Thank you.